Hi guys, and welcome to Journey Through to the Centre of the Earth. This is Activity 5, looking at metamorphic rock for Year 8. Okay, so as we learned in the last two activities, we've got three main types of rock that are formed: igneous rock, sedimentary rock, and the one that we're going to look at today, as shown in red, is metamorphic rock. Okay, so basically metamorphic rock is rock which has been changed, hence the term metamorphic, change in state, change in shape, change in structure of other types of rock under the influence of both heat and pressure. Now the heat comes from the magma in the mantle and comes from the center of the heat which is generated in the center of the earth. And some rocks can actually journey all the way down to that center of the earth and then come back again. And as a result, that heat which is generated is what's going to cause the changes in these rocks. The pressure obviously is by the fact that you've got nearly 6,000 kilometers worth of rock pushing down. You've even got 100 kilometers of rock just in the Earth's crust pushing down on some fairly jelly-like rock because it's been heated. The result is that compression together means that everything, all the gaps have been removed, any air pockets have been removed, making that rock for something which is going to be really, really hard. Pressure also comes in the Earth's crust due to the folding of the rocks. Now this is caused by the plate tectonic movement, where rocks come in, crash into each other and push, and that pushing again causes those rocks to be fused together. It's a bit like what a blacksmith does with, or used to do with steel, and they would actually fold the steel from one type to the next and make it incredibly strong. Okay, so basically what we get is one rock changing to another rock. So what I've put together here is some examples of both sedimentary and igneous rocks and how they've been converted into metamorphic rock under the influence of heat and pressure. Okay, so first up we've got sandstone. Now when sandstone is subjected to heat and pressure, it will go and form quartzite. Now obviously there's going to be more crystals which are going to form because the rocks will actually smooth and will cool a lot slower. So we get more crystals, we get all the gaps removed, and as a result we get a nice harder rock. So hence sandstone changes into quartzite. Next we've got limestone. Limestone will change into marble. Now marble, as you know, it has got huge uses, and you'll find that marble and a lot of the time was found in the Mediterranean, Italy, and hence that's where we get all these marble statues from. They actually come from huge marble mountains, which are literally cut out of, huge slabs are cut out of the mountains using diamond-tipped saws, and it's a very, very strong, hard rock. That's why we mostly use it for kitchen surfaces nowadays. Doesn't chip, doesn't scratch, useful type of rock. Incredibly heavy, but crystals well formed, and if you break open a piece of marble, you'll see all the crystals. You can just see it here in the picture. Shale. Now shale, as we said, another name for it is mudstone. That can then turn into slate. Now you'll find that slate, you can actually take a chisel. Once you cut the slate out of the ground, you can take a chisel, length on, hit the chisel through the layers, and you'll get a perfect slate. Now anyone who plays billiards, snooker, or pool often will know about a slate bed. Now what a slate bed is literally one big piece of slate which has been split straight down one of the layers, and it makes a very, very smooth surface, very flat surface, so the pool balls and the snooker balls roll on it very, very well. They also were used in some parts of the world for roofing tiles. The slates would actually have a hole drilled on the ends of them, and then they'd be nailed into the roof, and because they form a very flat surface, the result is the water would run off very, very easily. So very good use for slate. Slate can also be used as a cooling mechanism. They actually put it in bases of cellars and what have you, put the slate down there, stays nice and cold, you place your milk and what have you on there, and you've got your own basic refrigerator. So main thing for slate is that splitting, the ability to actually produce layers. What else have we got? Granite. Granite will go into form gneiss. Okay, again, an incredibly tough rock. So remember, granite is intrusive igneous rock, so it's hard already. Now it's been compressed and heated. We turn it into Nice. Note the spelling of nice, not Nice, even though it's said that way. Now, as well as this, I said that the immense heat, we've also got this folding. Now, the folding basically causes everything to be pushed together. So imagine taking something which is not a liquid as such, in a jelly-like form, and can be molded, and then you put huge amounts of pressure on it. The result is you're going to allow everything to combine a lot more easily. You'll get crystals forming. You may even get some changes in the actual minerals which are formed. So colorations may change in the different types of rock. But the main thing that you need to understand about metamorphic rock is that you've got huge amounts of heat, huge amounts of pressure from the weight above it, or due to folding, and as a result it produces huge, big crystals because it's slow cooling and it's incredibly hard. So some examples of folding can be seen here, where you can see the actual rock has actually been squished and pushed, and as a result you get these layers. They were flat at one point, now they've been all compressed together. Here's another one. You can see that the layers being formed, and you can see how it's buckled due to the immense pressure. And one more, just basically working through the idea that the rock is constantly being moved, constantly being pushed, and that's where that pressure. Now, if you think about a whole continent moving, then you'll give you some idea as to how much pressure we're talking about, and that's why the new rock can actually be formed together. And that new rock can actually be buckled up, and as a result form new mountain ranges. And for example, the Himalayas are a result of the India plate moving into the Asia plate, and what it pushed up was the seabed between the two plates, and that actually formed the Himalayas where Everest is. So they actually find seashells on Everest. Why? Because at one time it was underneath the ground, but due to folding, it's been compressed into an incredibly hard rock. Okay, so that means we've now run through all three main rock types: igneous, sedimentary, and metamorphic. It's important that you actually go through and learn the features of each of these and how they come about, because that's the sort of assessment that you're going to be given. Also look out for any questions that we've got in this course, which will allow you to sort of explain what the various types of rocks are showing us. Okay, so thank you for joining me, and join me again. I look forward to seeing you when we run through the next unit, which will be on the rock cycle. Thank you for watching.